Hey everyone, and welcome. So today, we're gonna roll up our sleeves and dive into a problem that, trust me, every single game developer faces at some point: a bug. A nasty little flaw in our game's logic. In our case, we've got a delivery driver game with a pretty major problem. Our driver can drop off a package they haven't even picked up yet. We're gonna fix it, and we're gonna do it using one of the most simple yet powerful tools in our coding toolbox, the Boolean.
So here's the game plan. First, we're going to take a close look at exactly what's broken. Then I'll introduce you to our secret weapon, the Boolean, and we'll start writing some code. After that, we'll test our fix, but you'll see we've accidentally created a new problem, an exploit. And finally, we'll add the finishing touches to perfect our delivery logic for good. All right, let's get started. First things first, before we can even think about fixing something, we have to really truly understand what's going wrong. Let's diagnose the problem in our delivery system.
Okay, so here's the core issue. Right now, as the game stands, a player can just start up, completely ignore where the package is, drive straight over to the customer, and boom, the game says, "Great job, package delivered." They get points, they get a success message, the whole 9 yards, without ever actually doing the main objective.
Now, this isn't just some small graphical glitch. This fundamentally breaks the entire point of the game. The whole gameplay loop we designed is built around the challenge of finding a package and delivering it. If players can just skip the first and most important step, well, then there's really no game left to play, is there? It's a major logical flaw, and we've got to fix it. So how in the world do we fix this? You might be thinking we need some complex, multi-layered system to track the package. But the real solution? It's incredibly simple. It's elegant. We're going to use a core programming concept called a Boolean.
So what is a Boolean? In code, we usually just type bool. Think of it like a light switch. It can only ever be in one of two states. It's either on or it's off. It's yes or it's no. For our purposes, it's either true or it's false. That's it. This simple binary nature makes it absolutely perfect for keeping track of conditions in our game. So we're going to create a Boolean variable that answers one very simple, very direct question. Does the player have the package? If the answer is yes, we'll set that variable to true. If the answer is no, it'll be false. This little true or false flag is going to act as the gatekeeper for our entire delivery mechanic. All right, enough theory. It's time to get our hands dirty. Let's jump over to our delivery.cs script in Unity and actually put this into practice. Let's write some code. The first thing we need to do is actually create this variable. We need to tell our script, hey, I want to create a new piece of information to keep track of. In programming, we call this declaring a variable. And we're going to do it right at the top of our script so that all the different parts of our code can see and change it. And this is it. This is the magic line. Bool has package. First, we say what type of variable it is. It's a bool. Then we give it a name. Now notice how we named it has package. It's a question, right? And the only answer can be yes or no, true or false. Naming your variables clearly like this is one of the best habits you can ever learn as a programmer. It makes your code so much easier to understand later. Now, here's a fun little question. We've created the variable, but we never actually told it whether it's true or false. So what is it right now? What's its default value? We could just Google the answer, but a much better skill for a developer to have is to learn how to find out for ourselves with a quick little experiment. The test is super simple. We're going to go into our start method. That's the code that runs just once right when the game kicks off. And we're going to add this line, debug.log has package. Debug.log is going to be your absolute best friend when you're coding. It lets you print the value of anything you want directly to the Unity console, so you can peek inside your code and see what's really going on. Okay, we add the line, we run the game, and we look at the console, and there it is. It prints false. So that's our answer. In C#, the default value for a Boolean is false. And you know what? That is absolutely perfect for us. It means that when our game starts, the system automatically assumes the player does not have the package. We don't even have to write any code to set it up. It just works. So our player starts the game and has package is false. That's great. Now we need to flip that switch. The moment our car drives over the package, we need to change that variable to true. We're going to do this inside our onTriggerEnterToD method. This piece of code already runs whenever our car collides with something. We already have a check here to see if the thing we hit is tagged as package. So all we have to do is add one simple line inside that check. Has package equals true. Just like that. The very instant we touch the package, our little flag flips.
The game now knows and remembers that we are carrying the package. Now for the crucial part. This is where it all comes together. We have our variable, and it's correctly tracking whether we have the package or not. But we're not actually using that information yet. We need to go to our delivery code and tell it to check our hasPackage variable before it allows a delivery. We'll do this in our onCollisionEnter 2D method, which is where we handle hitting the customer. Before, our if statement just checked one thing. Is the tag customer? Now we're adding a second condition using these two ampersands, and. This is the logical and operator. It means that for this code to run, both conditions have to be true. We must be touching the customer, and our hasPackage variable must be true. If even one of those is false, the whole thing fails and no delivery is made. Okay, the code is written. In theory, it should work perfectly, but any seasoned developer will tell you theory is one thing, but reality is another. It's time to save the script, head back to Unity, hit play, and see if we actually squash that bug. First test, let's try to break it the old way. We start the game, we drive right past the package, and go straight for the customer. We hit the building, and nothing. Absolutely nothing happens. We look at the console, and it's empty. The delivery message is gone. This is fantastic. The original bug is officially fixed. Success. Okay, but that's only half the battle. We fixed the bug, but did we break the actual game? Let's do a second test and play it the right way. We drive over, we pick up the package, so hasPackage is now true, and then we go to the customer, we make the delivery, and yes, package delivered shows up in the console. Perfect. The intended mechanic is working exactly as it should. So we should be celebrating, right? We fixed the bug. Well, almost. This happens all the time in programming. By fixing one really obvious bug, we've accidentally created a second, much more subtle bug. We've created an exploit. I want you to think about this for a second. After we make that first correct delivery, what is the value of our hasPackage variable? Well, we set it to true when we picked up the package, but did we ever set it back to false? Nope. So what do you think happens if we just keep bumping into the customer's house over and over again? And there it is. That's the exploit. Because hasPackage is still true every single time we make contact with the customer, the game thinks we're making another delivery. We can just sit there, bumping the house, and rack up infinite points or rewards. And let me tell you, if an exploit like this exists in your game, your players will find it and they will use it. We have to close this loophole. All right, let's head back to the code one last time. It's time to add our final piece to the puzzle and make this delivery logic truly bulletproof. The fix, once again, is beautifully simple and logical. It's all about closing the loop. If the action of picking up a package flips our switch to true, then it only makes sense that the action of delivering that package should flip the switch back to false. We have to reset the player's state. And if you look at the codes side by side, it couldn't be clearer. The fix is just one new line. Right inside our successful delivery check, immediately after we print our package delivered message, we add hasPackage equals false. So in the same instant that the delivery is counted, we tell the game, okay, the package is gone now. Okay, this is it. We've added what should be our final line of code. It feels right, it looks right, but we have to be 100% sure. Let's do one last complete test of the entire gameplay cycle to make sure everything works perfectly, with no bugs and no exploits. All right, here we go, full playthrough. First, we try to deliver with no package. It fails. Perfect. Next, we go and pick up the package. Then we drive to the customer. The delivery succeeds and we see the message in the console exactly once. Now for the moment of truth. We back up and hit the customer again. And nothing. It fails. The exploit is gone. And just to be absolutely sure, we can go find another package, pick it up, come back, and deliver it successfully. The system works flawlessly. So, let's just recap the beautiful, complete logical flow we've built here. 1, the game starts and hasPackage is false by default. 2, we pick up a package and it flips to true. 3, at the customer, the game checks 2 things. Are we at the customer, and is hasPackage true? 4, if both are true, it counts the delivery. And 5, the crucial final step. It immediately resets hasPackage back to false, ready for the next run. It's clean, it's robust, it's perfect. You see, what we've done here is so much more than just fixing one little bug. We've learned a fundamental pattern for managing states, for tracking conditions in a game. So I want to leave you with a question to think about in your own projects. Where else could a simple true or false check solve what seems like a really complex problem?
Think about it. Does the player have the magic key? Is the secret door unlocked? Is the super speed power-up currently active? The applications for this simple little tool are absolutely endless. Thanks for joining me.